All right, now, let's try to walk the conversion path. So what we're saying here is, hey, convert the polar coordinates to rectangular coordinates. So we're going from r comma theta to x comma y. Now, before we do anything about conversions, I would ask you to do this. Can you go ahead and make a rough sketch on where this point should be located? Where this point should be located? It's in quadrant where? Quadrant 2, right? So let's say roughly, here, okay, it's 5 pi over 6. So that will be here. And we say, all right, now we're gonna get the x and y coordinates. Now, before we get the x and y coordinates, like the accurate one, what can we tell about the x coordinate here? It must be negative. What can we say about the y coordinate? Positive. So you are not going to give me something otherwise. I don't want you to give me something positive x and negative y. That's just, doesn't make sense. Well, what do? Well, what's x again? X is r cosine theta. So, well, we have the r, we have the theta, and hey, let's go figure it out. R cosine theta. Okay, so do you still remember what's cosine of 5 pi over 6? Cosine of 5 pi over 6 is root 3 over 2. Root 3 over 2 times 4 is, well, actually not with 3 over 2 only, negative with 3 over 2. So you have negative 2 times root 3 when you have 4 times root 3 over 2. And that aligns with what we expected, right? We expected that x will be negative. It should be negative. If you don't get the negative, something is wrong. And then the y coordinate, use a different color. The y coordinate will be r sine theta, and the theta is 5 pi over 6. What is sine 5 pi over 6? One half times 4. It's 2. So if I have to label this point with rectangular xy coordinate, it will be negative 2 root 3 comma 2. Okay, and you may not know for sure if they are correct, but at the very least, the signs. You should know the signs. Okay, so this is how we change polar coordinates to rectangular coordinates.